Excellent. Okay, well, thanks again, Pete. And we'll move on now to Vladimir, because I think you mentioned you had to leave early as well.
Yes, I have to.
Excellent. So. Okay, we'll hand over to you if you want to start sharing.
Yeah. Could you see?
Perfect. Looks good. Thank you.
Okay. Termite range fault. Termite range fault is, it's very hard to tell everything about termite range fault in 10 minutes, 15 minutes time. But I will try to do very shortly. So I will show you probably geology map of termite range fault, then I will show you outcrops, then I will show you drill core, and I will show you seismic section, DMI section, and then final interpretation of this. So here on the slide is Century North Wall explosion. That's not termite range fault. Termite range fault is running probably 100 meters to the east. That's looking north. But termite range fault caused a lot of different style of deformation in pit. So this style of formation, we were just talking about the ramping, flat ramping reverse, box faults, or the tectonic injection, or monoclines, everything which could help us later to form to find out kinematics of this fault. Termite range fault wouldn't be significant fault if this termite range fault wouldn't have in proximity Century mine. So to talk about termite range fault, we have to talk something about Century deposit. Century deposit, as you know, is probably today mined out. It was 120 million tons with 10% zinc and 1.5 lead. And it was mined out by 3 different companies, Pesminco, Zinifex, Oz Minerals, and MMG, actually 4 companies. Deposit is hosted in siltstone and sandstone of Lone Hill platform, is undeformed in weakly metamorphs, and is preserved as downfaulted block. What's happened?
We're seeing the map. Is that?
Oh, what's happened? Did you hear me?
Yes, we can hear you.
Oh, that's good then.
Yep.
Okay.
You can see the map.
Here on geology map, here is termite range fault. Termite range faults has extension more than 15 kilometers. Along the termite range fault, there is no significant stratigraphic offset on any of the units. However, we could see many structure pattern or structure elements which could show some sort of faulting, such as veins, small faults, everything, and could help us to determine kinematics of this termite range fault. Termite range faults does not have magnetic signature. I didn't put here because it's no time for TMI, and also it does not have Bouguer anomaly. It's not gravity anomaly there as well. So fall is almost blind, except some of the places which is exposed. There is no surface expression, except here in the northern part where we could see thick quartz vein. Here down, it's very hard to find out. Here, just close to the Tallings Dam, there is very nice surface expression, which I will show you now. But fault is very well defined in seismic and magnetotelluric survey, which was done by GI Australia as part of P&D CRC. So that's the surface expression of termite range fault. You could see that's our main fault plane. That's all faulted, and there's the hanging wall default. That's 6 kilometers south of mine in Tallings Dam, and you could see it's very. We were talking about syncline. It's just big mess. It's just everything is, it's not a one fault. It's not a fault plane, it's multiple fault planes, which we'll see later on the section. This is fault which is on how does it look in drill core. In Termite Range, fault was intersected at the end of the mine, actually, when they did desperate exploration, drilling everywhere. And you could see that fault actually encompasses all possible, encompasses this hydraulic brecciation with carbonate towards veins, then is this shearing, then it's coming back in hydraulic brecciation, then it's coming through all these mineralized zones, which is, you could see that's the sphalerite, and that's the chalcopyrite here. So it's when it's fault intersected, so, and also this implies that the most likely this fault was main fluid path for mineralization of Century. Seismic, you could see on the seismic where Century mine is located here. So Termite Range fault would come here, and reversely lineament, which is probably much bigger, fault is coming from this direction. So in this section is just seismic section. So we will come to interpretation of this section. Here is interpretation on the migrated perigram sections. What's perigrams in seismic means is actually when you have continuity of reflectors times energy which is reflected. And you could see here on the left where approximately Termite Range fault is going. Here is just interpretation and here is pure. And then you have on the left is the much bigger fault which has very strong offset of reflectors. That's the reversely fault. And on some places you have this, you could see some mess big in reflectors. What does it happen? That's the most likely. We will go through and I will tell you in the next slides what could be. But here, that's the interpretation of the Termite Range fault on this side, and then associated antithetic fault. When we zoom in here, much closer, so we could see that actually on DMO sections, Termite Range fault is just, you could see, its section does not go over the deposit. It goes a little bit south of deposit because deposit was already mined. Section seismic was done 2006, and so it was, but some of the structure pattern is still preserved. What is here preserved? Here is preserved, as you could see, is just anticline, hanging wall anticline. It's like a oil and gas fluid trap. So we go further. So on the magnetotelluric sounding, we could see where this section went and where seismic line went. So TMI was conducted on two lines on the northwest of the Century mine with M2, trying to imagine Termite Range fault. Here is, but when you walk here, Termite Range fault intensity or displacement, or how every fault has embryo and it has termination. That's this Termite Range fault as well has in termination. So it's very hard to find Termite Range fault here. But with TMI, you could see still that there is some.
Vladimir, you still there? Yep.
I'm still there, but something happened.
You stopped sharing your screen. Do you want to start sharing again?
Yeah.
Yeah. Okay.
Did you get?
Yeah. So if you go back to slide mode. Yeah.
I will just go just a second. Do you get?
Not yet.
Not yet, just a second. I don't know what's happened with my.
We're just seeing a large white box saying resume slideshow.
Oh, because I got.
Would unshare your screen again. I'm just going to, I'm going to unshare for you. Now try sharing your screen again. And when you get the share screen, just do the one that has your presentation on it. Or if you've got one that says screen 1, do that one.
Yeah, I just don't get on another screen. That's the problem. Could you get now?
No,
Share screen now.
share screen. Yeah.
You have to click the blue thing that says share.
Yeah, I pressed. Do you get now?
No.
No.
Oh, here we go. Yes, we have it now. Or it's
Oh,
coming.
that's
Yep,
good.
there it is. Good.
So I will just not open. So on this case, as I said, that's it. You could see this on the chargeability, on the resistivity, lock resistivity, and you could see how is it related, where is actually Termite range fault going here and reversely flow fault going here. For more information, you could find out in the publication which was done by CRC P&D. So, and interpretation of Termite range fault. So what we could see here, so we have alt interpretation which was conducted by Geoscience Australia and CRC P&D. So in their interpretation, they interpreted, as you could see, reversely Termite range fault dipping to the east. So, and in new interpretation, Termite range fault is dipping to the west. What's actually happened? The biggest difference here is GIA Australia has asymmetrical domino pattern basin, while we have asymmetrical half graben basin. So, and Termite range fault is nothing else than antithetic fault, which is during the basin extension, just accommodated extension and make this little bit bigger hole, allowing, or depositional center, allowing deposition of fine-grained sediments. So in inversion, when we got inversion, Termite range fault in the first stage was normal, but then during the inversion, it was reactivated into reverse fault with a little bit left lateral segment. Here, some of these, when I show you before on the seismic section, some of the smudgy problems in reflectors is actually nothing else that dissolved salt domes. Why they are salt domes, which is quite understandable, because to form century so big deposit, you needed a lot of saline fluids, and saline deposit, the fluids could come from some of these salt domes. And Termite range finally in interpretation, what it changed. So how is it related? That's a Termite range fault on the slides here, reversely flow sides here, and that's the transfer faults between these two major structures, which accumulated opening of this basin. So we could conclude that Lone Hill platform is an asymmetrical half graben basin, northwesterly elongated with the deepest part on the western margin of the reversely lineaments. That's what you saw as well on the seismic section. Reversely lineament or reversely fault is major fault, which is actually easterly bounding, and it displays up to 9 kilometers. It's actually happened during the basin formation, and this during the basin inversion, this fault was in lock-up position, so we did not get much displacement along the reversely faults. That's the reason why we got on antithetic fault, Termite range fault, a lot of pressure out, and all fluids which were accumulated here just went up to the Termite range fault. So century deposit is located on the hanging wall of Termite range fault. It means if it's on the hanging wall, usually hanging wall is part where you have less pressure extension. So fluids, when they come, they were able to come and to penetrate into stratigraphy. And as well, fluids come through the sum of the stratigraphy of the Termite range formation, which is more oxidized, more permeable units, and they intersected these black rocks of H4 formation and reaction between oxidized and between reduced rock form deposit. Also, what we could see, what is very important, what we identified, that's the presence of soil diapirs. This drag geometry, this mess which was formed in seismic, actually showed that that's the, comparing with another examples, it's nothing else than dissolved diapirs in crust. And what we could say, in inversion tectonic style, this basin is partly inverted, as I say. There is some, both faults, Riversley and Termite range faults, they were normal, but during the basin compression, which wasn't much, so because these sediments or this sequence is mostly non-metamorphosite, but they are still partly reactivated. And this reactivation, when it goes, actually make enough fluid pressure to pump the fluid from one side, is like a bubble of the, when you put the pin on the bubble and then explode, and all these fluids went into black rocks and formed deposit. And century, probably this century, original century was much bigger, because century, what we saw today, is nothing else than downfaulted block of base metals or mineralization, which is preserved in the whole sequence. And there is still a lot to be done on the identifying Termite range fault, but if someone, I have heaps of information which I don't use more. So if someone would like, could send me email, and I would be very happy to send him if he's doing work or something. Thank you.
Excellent. Thank you very much, Vladimir. It was a great overview for me, because I've always sort of looked at the termite range just as part of a regional study, and never sat down and got through the data in detail. Now, does anybody have a question? Oh, so we've got one here from Robert Houston, and then Pete. We'll have to be quick though. So Robert Houston is just checking. It's an interesting talk, but forgive me if I misheard. Do you think the lack of definition of the termite range fault and associated geology by gravity is a problem, the survey spatial resolution not being high enough?
No, I don't think so. It's just because if you have similar rock density from one side to another side, and fair volcanics, which are quite deep down, they do not reflect gravity on the top. That's the reason. Yeah. So it's just because its basement is too deep, and basin rocks are very similar densities.
Excellent. Okay. Sorry, Pete, have you got a quick one?
Yeah. So where I've seen the termite range fault, which is down further to the southeast, it is definitely looks like it's got a strike slip component with pull apart basins and bends attached to it, and we're talking around the Big E time. So my question is, it's pretty clear from the seismic and all the data you present that it's not one of these transverse faults that I kind of presented. So, and the architecture that you showed is at 90 degrees to the architecture that I showed in my talk. So what do you think's happened between, the southern part of the Lawn Hill platform and sort of the central and northern part that has flipped the architecture at 90 degrees to itself?
Oh, it's just usual, because, as you know, fault could dip west and just with the time could dip east and this time. It's just oblique plane of the fault. As you could see on the seismic, there is no one typical. Just when you look this one, it's not typical one fault. You could see here how clearly these seismic reflectors are offset, but here as well. So it's quite, here is quite clear reverse displacement, which is not much. But here as well, this fault is just a zone which we even don't know. Some of this here is probably covered because it's limestone, so sucks some of the seismic energy on the top. But still, you could see when you get these parts here, or see this part, which is this big mess, it's probably some sort of, is it intrusion, or is it diapir, or is it something, what could be?
Yeah,
Yep.
I think one factor there, based on my regional understanding, would be controlled by underlying basement, because I think when you look at all the seismic lines across that greater region, you can see growth into structures that trend east-northeast and growth into structures that trend northwest, both. So I think you had extensional component of movement on structures in both orientations broadly during ISA superbasin time at some point.
Yeah. In Western succession, that's true what you said during the basin development, but during the basin closure, inversion, certainly, as you could see, these all reflectors, actually they have a hanging wall, so they impose some sort of up movement, so some sort of reverse movement.